Yeah, first I would like to thank everybody at Chinmaya University, especially Dr. Shilpa. I don't know where she is. Okay, you're at the back. Okay, and everybody for inviting me. Over 2 days I realized I am an outlier in this conference. I do not do qualitative work. I do science. A lot of these things have been kind of trashed over the past 2 days. And I want to make an argument that you can study, or we should try to study, whatever we want to study about us, anything that we want, using science. When you make a choice of different methodologies, whether it is quantitative, mathematical, statistical, qualitative, you are really making a choice. Of course, every methodology has some advantages, has some disadvantages. Every method can give you something, but not everything. So if you want, for example, causal explanations of phenomena in nature, then I don't think you're going to simply do it by doing only qualitative research. It's not possible. It's a limitation of the methodology. Similarly, if you do qualitative research, it's good, you can get some information, but ultimately you are making a choice of languages. Essentially, if you do qualitative research, you are simply saying that I am happy with whatever is provided by the kind of languages we already use, English, Tamil, Sanskrit. If you do science, as somebody famously said, what you find is let me quote the phrase, unreasonable effectiveness of mathematics. And mathematics was also done in classical India as well. So there is no reason for us to shun away from mathematics. One of the things that happens, especially in social science research, is that people are told to kind of stay away from mathematics. In fact, a lot of choices are made based on, I really don't like mathematics. That is for people who do physics or chemistry, and I will do psychology or sociology or whatever it is, and then I don't want to do mathematics. So mathematics is very effective, and we will see. The third component is experimentation. While we cannot do experiments freely outside, we can do experiments in the laboratory. And these two things are not mutually exclusive of each other. Again, each give you different kinds of information, and you can build a coherent story only when you have all those things in place. Okay? With that kind of preamble, I'm going to talk about time. I will start with our experience of time. I will kind of shift to the second part, which is a shorter part, and I will talk about consciousness with some emphasis on time as well. Okay? I will talk about 4 aspects with respect to experience of time. All of us experience time. As I was telling somebody, time is a bit peculiar due to multiple reasons. One reason is that if you are familiar with perceptual theories in Indian philosophy as well, there is a lot of talk about sense organs. Do we have a sense organ for time, exclusively for time? We have eyes for vision, presumably. We have ears for audition. We have skin. But what about time? It is something we perceive, though. All of us have sat enough in, since this is an academic setting, boring lectures which never seem to end, and time passes very slowly. And sometimes you are involved in your activities so much, time flies, and you simply say, oh, it's just time passed very quickly. I'm sure all of you have had this experience. If you have not had this experience, raise your hand. Right? So all of us experience time. It is something that we experience, something we even talk about. So the question is, how does it happen? And I'm not going to talk about everything that we know about experience of time, but important thing is even any kind of experience that you have, whether it is a visual experience or an auditory experience or actually a kind of unified experience that you have, happens in a subjective timeline. It happens in time. As in physics we say time has a direction, right? There is past, present and future. You don't have it for space. Space is just, there is no direction to space, right? And our ability to perceive time, it plays an important role in lots of things we do, right? There was an announcement made, the talk is going to start in 4 or 5 minutes. It's again about time, right? Whenever we start studying something as a science, the first question invariably comes is, how are you going to measure it? Because if you are not going to be able to measure something, then it's almost impossible to do anything with it. So the question is, how do we measure your experience of time? So what I have put is not exactly the only methods, but 3 common methods that we use to study how people experience time. Let me go through them. It's methodological, but many of you may not be familiar with this. The first method is kind of an obvious method. It's called verbal estimation. The basic idea is simple. I say, show you a video or a picture for some time, and then I ask you, how much time do you think passed? And I ask you to give actually a number, okay? Now, it sounds like, how will people can do it? The answer is, people can do it reasonably well. It's not that people give accurate numbers. We are not interested in that. In fact, there is a difference between what you can measure by a clock, the objective time, and what people report subjectively, okay? They do not match, but that's not important. But people can do this, and we can use this information effectively to study how we experience time. The second method is reproduction. So essentially, again, I can show you a video, say for, I don't know, some 10 seconds, and then I can say that, well, whatever time that you experienced, you just, usually you can do it as, say, start, you just wait for that much amount of time, and then you say stop, okay? It's essentially a reproduction of the same duration. Typically used for very longer durations, not for shorter durations, but it is something that is commonly used, and we have used as well. The third method is a more what is called a psychophysical method. It's called bisection. The idea is simple, that if you are going to present certain stimuli or objects on the screen for certain amounts of time, it will span a range of time, say 1 second to 2 seconds. Now, what you do is you train participants to say that, well, what is 1 second? This is how much it lasts. What is 2 seconds? This is how much it lasts, so that people are aware of the endpoints. Then you can present any stimulus for any duration in between, and then ask them, is it closer to the short one or the long one? Now it becomes what we normally call a 2 alternative forced choice task. Okay, so now you are making a choice between 2 alternatives. This duration, is it closer in my experience to that one or this one? People can do this, and with that you can construct a curve which we can use to study. Okay, and I will show you an example of this as well as we move on. So these are 3 reasonably common methods that is used in studying our experience of time in the literature. Now, as I said, our experience of time is exactly not the same as what you say your clock will tell you, right? So a lot of factors influence our experience of time. Some are listed here. I'm not going to go through all of them. If you are interested, we can look at them. So for example, this is temporal factors, something about speed of stimuli, how quickly something is moving, whether something is moving, whether something is flickering, the size, whether it is an object or not, whether how big of an object it is or small an object of it is, all of these things affect our experience of time. Okay? These are not things that I study too much personally, but they are there. What is on this side are things that I do study, and we will look at some of them. Intentions, our own intentions influence how we experience time, and I will show you an example of it. How a particular object or a piece of information is associated with us, with, you could call it self, that affects or ego, whatever terminology you want to use, that also influences time, and I will show you an example of this. And how we pay attention also influences our time. There are a lot of studies on how attention influences our experience of time. I will go through one of them. Okay? Now, there is a particular hypothesis. It's a bit abstract, but I have put it for people who are interested in philosophy. There is something called a structure matching thesis. It was actually kind of explicitly given by Ian Phillips, who is a philosopher. Let me just read the quote. The way we go about trying to answer the question concerning the temporal structure of our conscious experience is by making a judgment about the temporal structure of the apparent objects of consciousness, and then by taking our experience to be structured in the same way. Now, I'm not going to talk about all the implications of this, but the basic idea is this, right? Time is peculiar in way. Experience happens in time, and in effect, we also experience time. So, for example, take color. We experience color, but we will not say experience happens in color, right? It doesn't work that way. But time is one where you can say it both ways. I am experiencing something in time, okay, as well as I experience time as well. Okay. So this makes time a bit unique when it comes to other perceptual experiences that we have. Now, various models of time perception, and there are many models that are currently available in the literature, and I will describe 2 or 3 very briefly. They do not talk, or at least our criticism is that they do not very well take phenomenology or experience into account, okay? And I will tell you in what way. And what we really want to show is this, what this needs is a change in felt time solely by a change in experience, but we would like to say even without change something out there, okay, whatever an object out there. How do we actually study this? We study this using something called a Necker cube. I was just actually showing it to one colleague here yesterday. Many of you may have seen this in maybe undergraduate textbooks or websites. If you keep looking at this cube, and you can do that yourself, it will change its orientation automatically, right? And what will, if you have enough time, say 5 minutes, and you keep looking at this, then what you will get is a time series like this. It will keep changing. The duration for which a particular orientation that you experience is not constant, it's variable. In fact, we can show it's actually a nonlinear dynamic time series. And this experience that you have is interesting because, at least for us who study experience in the lab, visual or perceptual experience, is the fact that what is on the screen does not change. Okay? It's the same thing on the screen. You are not changing anything. What keeps changing is your experience over time. It goes, sometimes it's this, sometimes it's that, this, that, and keeps on alternating. And this provides us an interesting way to study, and this is what we do here in this experiment I'm going to show you, about how our experience of time changes using this particular stimulus. Okay? Now, there are theories about how this happens with respect to the brain. I know there are not many people who study the brain here. I will just briefly still mention terminology. There is something in the brain, what you can do if you measure, especially from outside the brain, are oscillations of different frequencies, okay? And what you have are different frequencies in different ranges. There is something called theta range, which is 4 to 8 hertz. There is something called gamma range, which is usually from 40 to 60 hertz, okay? Now, these two oscillations, they are actually coupled with each other. They are hooked up. Think of them as two oscillators that are hooked up. They are coupled with each other. When they do it, you can see this is actually what is called a phase difference. If you have an oscillation, a sinusoidal wave, if you are done in school, you have what is called phase, the angle, right? And these two oscillations are either synchronized. In this case, the phase will be 0 or very low, which is what happens here when you are actually perceiving something. When you make a transition to another percept, it again happens here, but there is a small period of time, although it's stretched in this graph, where you actually make a switch. And it's not, while this diagram shows it happens instantaneously, in reality, it still takes a little bit of time. So what we are actually interested in is how much time that is, okay? Or how that affects our experience of time indirectly to say something about that. So this thing, which essentially for some amount of time, they kind of go out of sync. These two oscillators go out of sync. So they are in synchronization, and then they go out of sync very briefly for a moment, you can think like that, and then they come back again because you have another experience. Now, this period is essentially what we want to focus on and how it affects our experience of time. Now, I won't go into too much detail with the actual models and the hypothesis that each of these models predict. There are, in time perception research, there are one class of models which are essentially what are called pacemaker accumulator models. The basic idea is very simple. You have a clock. The clock has a lot of pulses. You have an accumulator which essentially grabs these pulses. The more number of pulses you grab, it feels like it's more time. Less number of pulses you grab, it feels like less time. Okay, that's simplistically, that's what it is. They actually predict that if there is a perceptual switch in your experience, you see something and then you see something else, then in that case, you actually should have, when there is a switch that occurs, and if there is a duration in which that switch is occurring, then you should feel it as longer felt time, okay? Time should expand. In intrinsic models of time based on coupling, which I just mentioned, if you have a period during a switch, and in that switch the coupling is lost, the prediction is opposite. You will actually have contraction of time. So the felt time should contract. And there are models that produce that it won't make any difference, okay? They essentially produce a null result. Essentially, this is what we do. You see this cube, and I will show you a video of this. You pass this rod through the cube in a way that it doesn't switch, or sometimes it can switches. There is actually what is called a geometry violation here. Based on it, it may not switch or it may switch. And we ask people to estimate time. There are 4 times that we use in the study: 400 milliseconds, 800, 1200, and 1600 milliseconds. So 0.4 seconds to 1.6 seconds if you're interested in time. Okay, so just hold for a moment this in front. Okay, if that is the case, press again. For some of you, when the rod passed through, I don't know now, it's difficult to do this. Did it switch when the rod was passing through, at least for 1 or 2? Okay. Okay. So that's it. So it depends on which orientation, which percept are you seeing. If you are seeing the cube one way, it will not switch. If you are seeing the cube in the other way, it will switch. What is happening on the screen is exactly the same thing. Okay, still, there's nothing on the screen that is changing, but your experience either may change or may not change. So we can look then at what is the difference when it changed versus when it did not change. Okay. So this is what we do, and what you find is we ask people after this pass through, we ask them to verbally give a number, estimate the duration of how much time it took for the rod to pass through from left to right. Okay. We also ask them whether there is a switch in their experience or not. Remember, this is in their experience, not in the stimulus, right? And what you see here is that at 3 durations here, 400, 800 and 1600, when there is switched, it's actually shorter than when it did not switch in their experience. So when they had a switch in their perceptual experience, the felt time contracted, it was less. Okay? There was no difference here, it's not important. What we really do is, actually this is what we do, we take each participant gives an estimate of these 4 durations. We fit it with a particular mathematical function. For those who are interested in the math, I have given the function here. It comes from a particular model called a dual clepsydra model. But the basic idea is that you fit this function with a particular mathematical function, this curve, and you can estimate 2 parameters. And you can see them here. There is a parameter called eta, there is a parameter called k. The only interpretation of these 2 parameters is eta is something to do with what is called an extrinsic parameter. That is, it is something about what happens, think of it as outside. And k is a parameter, it is something to do with what happens inside the system. So think of it as something to do with the mind. Okay? So k is an what we call an endogenous parameter to the system, and eta is an extrinsic parameter. What we find is that this parameter k is different in the 2 conditions, which means that whatever is causing or related to this change in your experience of time is reflected by changes in k, which is something internal factor, a factor internal to the mind. Okay? It's an endogenous factor. And that is linked to the way you experience, in this case, this particular Necker cube. Okay, so models that are based on clock actually cannot explain these results, and it doesn't account for phenomenology. Various propositions like, I've not really defined them, coherence intervals, cognitive cycles, which are based on what we call the present moment, right? There is always a present moment in your flow of experience. William James called it specious present. There are others who have different terminology. They can predict, and phenomenologically the switches appear pretty immediate. When it switches, it looks like it switches instantaneously to you. However, it's not instantaneous. It still takes a little bit of time, and you can see that kind of in this difference. Okay? In a sense, this difference reflects that time that actually takes to make the switch. Okay. So the basic idea is this: when there is a switch, initially you have one perceptual event, something you are experiencing, it switches into something else, and here is where the switch occurs. When the switch does not occur, you have essentially one single continuous event. And what happens in your experience is that the time it takes for the switch to occur, it's almost like it's deleted from your experience, and because of that, the felt time gets shorter. Okay? So one of the things we study in terms of attention is essentially using these kinds of stimuli. What is so nice about them? Well, you can see this is a big letter made up of small letters. Okay? So this is, well, the letter H in English, and it's made up of number 8s. Okay? Now this big letter is what we call global. The small letters are what we call local. The good thing about this is that we can simultaneously manipulate information at 2 different levels and then see what happens. So I can ask you to pay attention to the big letter, or I can ask you to pay attention to the small letters. Okay? And I can manipulate attention that way. Either you focus on something which is small, or which is something which is bigger. Okay. You can present these stimuli for different durations. You can ask people to estimate, and this is the function that you get. I mean, this is actually fitted with straight lines. This is not a straight line. I just joined by connecting line segments. But the basic idea is shown here. Okay. These, by the way, this study was also done with people who meditate. These are concentrative meditation type meditators, particular type of meditation called the Sayat Samadhi meditation. Let's just focus on non-meditators first. What you see is a difference in slope. It's not very clear here because of the way this figure is done, but it's clear here. So if I ask you to pay attention to the global level, then the slopes of the function, which is the x-axis is objective time that you manipulate, y-axis is reported time by the participants. This is perception, this is, think of it as the world. There is a difference in slope between global and local. The global has a much higher slope than the local. So the way in which your experience of time changes depends on whether your attention is local or global. Okay, that's the basic idea. Okay. Now, if you are a meditator, you can see what happens. In this particular type of meditation, they concentrate, they focus on a particular whatever mantra or object. So what happens, the global does not change at all in this particular case. What happens here is the slope for local goes up. Now there is no difference between local and global anymore. Both slopes are equal. Okay? So whatever the difference is there between local and global in people who did not meditate kind of goes away here among meditators. Okay. The third thing, which I will do it quickly and then move on to the last part, is that even our intentions influence how we perceive time. A lot of time we want something to happen, right? Many of us want this to happen, that to happen in our life, or certain events which we experience. The question is, what is the difference between events that you wanted to happen, you desired, or you had an intention that it should happen, versus events that happened which you did not intend, okay, which you did not desire. The basic idea is, how does it change your experience of time for those events? Okay, there are other aspects which I'll be happy to talk about offline. I'll just go to the results simply because we're running out of time. Basically, it's to say you have an expansion of time. That is, if you get the desired event, whatever you desired, then time expands. If you get what you did not desire or what you did not like or whatever, time contracts. Okay? That is essentially the basic idea. If you have a stimulus that is associated with yourself, so in the laboratory what we do is we simply associate, say, you with a circle. It's very arbitrary. People come into the lab. We just associate an arbitrary geometrical shape. It's like your name, your parents gave you something, arbitrary, right? And then attach it. You just say these two go together. That's all it is. You train people for 10 minutes, 15 minutes. That's all you need to do. Then what you do is you measure, you ask people to press a key. These shapes come, and you ask people to estimate the time between when you press the key and when these shapes appeared on the screen. Okay? That's the time you are estimating. And what do you find? If a particular shape is associated with yourself, you report that time to be shorter. Okay? If it is associated with you, essentially you feel it closer in time. If it is not associated with you, the shape is associated with stranger, you report it to be farther away in time. Okay? So the point, the sum total of all this is essentially this, that various factors, whether they are factors which are part of the object or the stimulus, or internal factors, could be what you wanted, what you desired, how you pay attention, and so on. All of these things influence how we perceive time. Okay? That's okay. So there's very little Indian so far. This is the conference on Indian knowledge systems. So finally, I kind of decided and put something which is very important for Indian philosophy. And this is that the question is basically pretty simple. Most of you may be familiar with this question. Is consciousness without content is possible? Now, there are a lot of science and some philosophers would argue it's actually not possible. In Indian philosophy, it is supposed to be possible, right? The earliest reference, as most of you are experts, come from Mandukya Upanishads, where you have a description of the 4 states of consciousness, right? You have wakefulness, dreaming, and sleep. This is one particular translation. It doesn't matter whether this is exact translation. The only point I want to make is that this fourth state of consciousness, the Turiya, is an empty state, right? It does not have any content. It is not supposed to have any content. So the question is it possible? Does it even exist, right? As a scientist, you are always taught first you are a skeptic. So you always ask the skeptic's question first. Does it exist? If it doesn't exist, well, then we don't have to bother. We just simply then need to explain why people think it exists or why people experience. Remember, we are not talking about the experience per se. People may experience a conscious state as though it has no content. A skeptic will say, yeah, you did have that experience, except that it is still an illusion. Okay? That's what a skeptic would say. And I will give you a skeptic's theory as well, and that comes from Thomas Metzinger, who is the philosopher. So if the question is, does Turiya exist at all? And can it be studied scientifically, if at all can be studied? Or at least can we make sense of it, or start making sense of it? If it does exist, then the question becomes, well, let us say it exists, then the question is, how do we study it? Of course, if you are a sage, you don't have to bother with this issue at all. You just have the experience and you are perfectly all right, okay? This doesn't apply, I don't know, to Ramana Maharishi. He would not care. But if you are in academics like us and we want to understand and explain it to a skeptic, then the question is, and if you want to study it, how do we study it? Is there ways of even approaching them? Forget about solving them. We're not even close. But the question is, how would we even approach this? And all I'm going to say is something about a couple of ways in which you may try to approach it. Okay, that's all there is. But before we do that, so I will talk about 2 things. One is dreamless sleep experience. The second thing is essentially located in some relationship to properties of consciousness. And the property that I have in mind is continuity, and I will talk about that. This is the Arras model, so-called Arras model by Metzinger, and this is a quote from his paper. There are some technical jargon here which is related to a particular part of the brain, the ascending reticular arousal system, which is very important. If you knock it off, then you essentially you become unconscious, you are in coma or whatever it might be the case, right? So this is very critical. So the minimal form of conscious experience is constituted by the content of a predictive model. The word here is predictive model, and let me just give a brief background for those who may not be familiar. Majority of the models are, one of the most popular models out there is the notion of the predictive mind, if you're talking of the mind. If you are talking of the brain, then it's the predictive brain. The basic idea is very simple. At every instant in time or every moment in time, your mind is always predicting what's going to come next. Okay? Then something happens, for now we will make it as an external perception. Something happens in the world, you get some information, you perceive something, then you compare the two. Then there is an error. So you expected something, you predicted, you got something, there is an error, and this prediction error is what drives further what happens in the next moment. and this goes on in time continuously. Okay? So this notion of a predictive mind, that it constantly predicting what's going to happen in the next moment, checking that whether the prediction was true, if there is an error, revise, keep doing forever, I guess. And this is, in nutshell, is what is meant by a predictive model, or what underlies this. Okay? And the basic idea is that this RS system determines the brain's general level of activation. So essentially, Metzinger argues that contentless consciousness, is a skeptic on this, is an illusion, and the pure conscious state actually has a non-conceptual representational content. Okay, so this is philosophy. So essentially, he is arguing that this particular pure conscious state still has content. The only claim he is making is that this particular content is non-conceptual representational content, but it still has some content. It's a special content, but it's not contentless. It appears to you as though it is contentless. Okay? The non-conceptual content, because it is non-conceptual, represents empty or non-representational. Its peculiarity is that its content itself is emptiness. Okay? And that's the reason why, if you experience this state, you report it to oh, there was nothing in my consciousness, it's empty. Okay? And Metzinger argues that contentless phenomenal state actually carries an abstract form of intentional content. Now, he goes through various properties of what is important to look at if you have a minimal phenomenal experience. I'm not going to describe all of them. I'm already told I have less time. But I will just say that there are many properties: tonic alertness, absence of intentional content or content of absence, self-luminosity, introspective availability, epistemicity, and transparency. Okay, so I'm just reading it. If you want to talk about any of them, we will talk later. And what Metzinger has done is, for various states of consciousness, going from normal waking, here, full absorption, lucid dreams, lucid dreamless sleep, dream sleep, deep sleep, minimally consciousness state, you can then make a matrix of these 6 properties. You can think of them as properties. And if the color is dark, that means you can think of it as more or less. Okay? And that's are present or absent if you want to make it as a dichotomy. And this gives you an idea of how to compare different states of consciousness according to him. Okay. So essentially, the idea is that this minimal phenomenal experience is actually, you have a causal model of this RS set up in the system as a predictive model of the RS signal, and that model, because it's hidden, and that's the reason why this particular state of consciousness has this feeling of emptiness, that it has no content. Okay. That's his explanation or a proposal. Okay. What are the closed states of consciousness without any content? Of course, when we are normally awake, right now you are all seeing me, so your conscious experience has some content, right? You are seeing me, or you are hearing me, or whatever. One place it shows up, both in scientific research as well as in Indian philosophy, is what happens to your consciousness in sleep, right? Many of you who have interest in Indian philosophy, there has been debates about what happens to your consciousness when you are asleep. It's there or it's not there. So the dreamless sleep experience is something that you can describe as a pure temporal experience, and there are ways and means people have started studying in the lab dreamless sleep experience. And the claim is that it has no intentional content, but there is, of course, this particular one which I read and discussed in the literature a bit more is the debate between Nyaya and Advaita about what happens during sleep, right? The only point I have put here is that, and somebody can correct me if I'm wrong, Nyaya does not allow objectless cognitive states. So you still have to have content. So this issue is a bit tricky. For Advaita, of course, it's not a problem. So when you have a dreamless sleep experience, then you don't have a sense of self at all, presumably, or at least you don't experience it explicitly. There seems to be a phenomenon now, and this is argument made by Jennifer Wind, and the recognition of the absence is based on what is called retentional aspects of the now. This is a kind of technical term, actually comes from, it's in the Indian philosophy debate, it is usually couched in terms of memory. In Western phenomenology debates, it's usually couched in terms of pretension and retention. So if you have a now, the current now of your experience, it has some kind of a trail on both sides. This trail on this back end, think of it as a plane which has some smoke going behind, okay? That trail is what is called the retentional aspect. And the argument is that you don't have any experience here, but this retention, this kind of tail here, which essentially then tells you, oh, consciousness was actually present here, okay? Anyway. In terms of continuity, there has been a debate, well, with everybody, but what I have put here between two Buddhist schools, right? Now, interestingly, Buddhists actually argued for discrete moments of experience. So for them, consciousness is discrete. It's not continuous, okay? You have various, and of course they had a calculation as well, lots of moments, very brief. Whether those particular calculations are right or wrong, it's not an issue. But the basic idea is that the moments of experience themselves are discrete. But it raises a particular question though, and the question is put here. How consciousness manages to function coherently given that it is gappy, it has gaps. It may be a very small gap. If consciousness is strictly momentary in the sense that there is no consciousness whatsoever that persists during the gaps, then what accounts for its coherent functioning not only from moment to moment, but also across longer stretches of time, okay? For example, what accounts for longer lasting traits of consciousness such as the attentional stability arising from meditation practice? Why don't the gaps between moments of awareness disrupt these continuities? Okay. This particular quote comes from an interesting book I would recommend by Yvonne Thompson called Waking, Dreaming and Being, which talks a lot about both science and Indian philosophy. And how do we address this? Now, for the Buddhists, if it is discrete, you need a way of somehow connecting it, right? What happens in the gaps question has to be answered. One possible way to answer it is to propose this notion of active versus passive consciousness. So the passive consciousness, which presumably, which provides the basis of continuity of individual, sometimes it's translated as life continuum or fact of existence or bhavanga. And the basic idea is that this passive consciousness is something that is there, and whatever your experience is, it's like multiplexing. For those of you who are familiar with engineering, it's kind of laid on top of it. And then what you have is the sum total of the two, okay? It's essentially something like that. The Yogacaras actually proposed Alaya Vijnana, and that is supposed to be continuously present all the time. So both of them propose something that is present all the time, something that is momentary, and what you eventually end up experiencing is a kind of combination of the two. And what is continuous, right, is essentially it's a state, well, this is possible, I'm just now hypothesizing, without content. The contents are discretely coming and jumping here, and then they get added to what is contentless. Think of it as a river with some stones in it, okay? So this notion, this debate about continuity versus discrete is a very prominent debate in the science as well, right? People have been debating whether conscious experience is really continuous or really discrete. This goes back to debates in physics as well. For those of you who know whether it is continuous or discrete, we have ended up with quantum mechanics, which actually says it's all discrete, at least at the quantum mechanical level. Even though this looks continuous to you, if you are, according to physics, it's actually discrete. There are gaps there, which is not visible here, right? So you have quanta. So whether the underlying reality itself is continuous or discrete, it's up in the air. We'll continue to debate it. But the continuity property, in as so far as we can bring it to the lab, and if we can measure or distinguish between continuity and discreteness, that may provide a way of answering this debate about consciousness without content as well, or at least that's what I think. Okay, so let me just conclude. Various aspects, conscious content, attention, intentions, self-association, they all influence how we experience time, and the presence of contentless state of consciousness has it's actually very important for all theories of consciousness, whether in philosophy or in science. The functional theories of consciousness, the positions like functionalism, will not allow contentless states of consciousness in science as well. And we would need novel paradigms to study and theorize about it. And of course, it seems like if you actually realize such a state, it does seem to change people's life. People do report it, and this is the only thing I have about something to do with well-being, okay, since I saw consciousness and well-being. And we do need to measure the impact this has on, the realization has on your day-to-day life. And that's another way we can still study it, probably an indirect way of studying it, but I still think that's important as well, okay? Let me thank all my students. They are the ones who do all the work, and I just talk about it. So this is kind of a bit of opposite of what people have been doing. These are the ones that I want to acknowledge, not my gurus, my students. They do all the work, and I get some credit. So Ishan Singhal, who did the perceptual switch experiment, Amrinder Singh, who had done studies on meditators, and Mukesh, who had done studies on intentions and all that. That's it. Thank you.
Hi, good morning, sir.
Hi.
Thank you for the lovely presentation. Actually, I had a question about the verbal estimation that you presented. So has there any study being done about how the difference in the estimation and the psychological condition of the mind and the correlation between that? Because I wanted to know about that.
Well, all the things I just presented are psychological conditions of the mind.
No, as in if they are suffering from any illness and...
Oh, it does affect. So something that I do not study. So a lot of people have shown that if you have various disorders, your perception of time also changes. Just a quick out the top of my head, for example, ADHD children, they have a changed sense of time as well.
Okay.
Many, schizophrenia, depression, I mean, pretty much every disorder changes your sense of time as well.
So, I wanted to know, whether this can be also used as a tool to, identify whether...
Some do it already. There has been work on using it as a tool as well. I mean, if you write to me, I can point out to something later.
Sure.
But yes.
Thanks very much for a exciting, stimulating presentation. In that matrix which is being shown, maybe you can hypothesize, and this is my question, I would like to pursue that, unresponsive wakefulness syndrome, and then the minimally conscious state. I think these are being classified as two, but with my little experience of some sadhana, little bit of thanks to my mentors and gurus, even the unconscious experience is of the different variety. And so, for example, if someone does Soham sadhana, there is a certain type of experience which is for a common person, lay person who is not trained in the cognitive science, would say it's a contentless. Transcendental meditation will have a certain deeper type of, another type of contentlessness. The Shunya meditation will have a very, very different type of experience. So there's a possibility of further refining this classification. There might be some clarity.
See, the issue is this, right? If you want to give a typology of contentless states, normally the typology we give about our experiences is actually based on content. So for example, how do you distinguish between a visual experience and an auditory experience? Well, because the visual experience has visual content, the auditory experience has auditory content. It is actually the differences in content which enables you to classify them as different kinds of experience. Okay? Similarly, the kind of content in dream is different from the kind of content that is present when you are wakeful. Again, the differences in content is there, right? So for example, I can fly in dreams, but I cannot have a flying experience.
I fully appreciate this logic.
So all I'm saying is, if you postulate that there are different types of contentless states, but still they don't have content, then the difference has to come from something else, unless we can clearly say what that something else, and we can
capture that.
Yes. That, of course.
So just my my hypothesis is the difference, if we are seeing from the Manomaya Kosh and Vijnanamaya Kosh perspective, there's a problem. But if we look at the Pranamaya Kosh, the continuities might be because of the Pranamaya Kosh, may not be from the Manomaya and Vijnanamaya Kosh.
Except that you need to come up with a way to study and show it to the skeptics.
Yes, but before any measurement, we need to have a hypothesis and conjecture.
It's possible.
I'm just conjecturing.
Yeah, sure. I mean, we have to conjecture.
We have time for a last question.
One question.
Yes.
Thank you very much, Professor, for a wonderful presentation on the core questions on consciousness and how we can study it scientifically. I have two questions, Professor. One is your Necker cube experiment. Was it done on meditators or normal subjects? So I'm particularly interested that is it possible to have a delayed switch in case you have been training your attention? Because when meditators attend and they say one-pointedness, what they are trying to do is to not switch. Basically, they're trying to not switch consciously in their internal objects. So that's one question.
Should I answer it? Okay. So this particular experiment we have not done with meditators. Okay. So this one is, we just wrote this paper up, we just completed it.
Right.
But we have done Necker cube experiments with meditators. As well as non-meditators, and what we have done is that we essentially present, well, the Necker cube stays on the screen and people keep reporting switches. And then what we have found is that you can, by the way, this switching is something that can be controlled voluntarily, even by us. We don't, I mean, those of us who are not expert meditators, even we can do that. But of course, meditators can both hold it for a longer period of time,
right,
as well as make it switch faster as well. So they can do both. This is what the data that we have shows. So in that sense, meditators are better able to control their experience. This particular experiment we have not done with meditators, which hopefully I think we will do eventually.
Thank you. My second question is, what does Metzinger say? Elaborate on non-conceptual, non-representation, what he says.
Non-conceptual representational content. Okay.
What does that mean?
Well, the issue about in theories of perception is that what kind of a content it is. So for those who are not familiar with this, there is something about conceptual content. For loose way of talking about it, simply think like things that you can put on words. It's not a great way to define it, but for now I will survive with it. Non-conceptual contents are not concepts. So they are still content, but they are not concepts. Indian philosophy as well as other Western philosophy allows for non-conceptual content. There has been a long debate about whether all content is conceptual or not. Metzinger argues this particular state has non-conceptual. If it is conceptual, then it's a problem for him, because then people will be able to report about it in principle. So he has to make it non-conceptual in his model. We can talk more later.